When looking at graphs and charts, there are three levels of questions that we can ask. So in this video, I want to break down those three different levels of questions about graphs. The first is known as reading the data. This level of comprehension requires a literal reading of the graph. The reader simply lifts the facts explicitly stated in the graph or the information found in the graph title and axis labels directly from the graph. There's no interpretation at this particular level. The second level is reading between the data. This level of comprehension includes the interpretation and integration of the graph and the data. It requires the ability to compare quantities, so for instance, greater than, tallest, smallest, as well as use other mathematical concepts and skills like addition, subtraction, multiplication, and division that allows the reader to combine and integrate data and identify the mathematical relationships expressed in the graph. So these questions are asking which one has the most, the least, how many more, how many less, things like that. The final level is reading beyond the data. This final level of comprehension requires the reader to predict or infer from the data by using existing knowledge and knowledge developed from reading the data and reading between the data for information that's neither explicitly nor implicitly stated in the graph. So let's do an example of all three of these types of questions. Here I have a graph. We polled our class to see what they wanted for lunch, and we made a graph of how many wanted pizza versus how many wanted hamburgers. So let's look at our three different levels of comprehension. Let's start with read the data. An example of the read the data question, how many students chose pizza for lunch? I can look at this graph, see that we have 11 students that chose pizza for lunch. This would be a reading the data question since we were able to lift this directly from the graph. And it didn't require any interpretation or any kind of calculations or anything like that. Next, let's look at a read between the data question. How many more students chose pizza than hamburger? For this problem, we would see that there are 11 that chose pizza. For hamburger, we had 6 students. And so to figure out how many more, we would need to subtract this to get a total of 5. And this is a reading between the data since it required us to compare the quantities and use other mathematical concepts, in this case, subtraction. Finally, we want to read beyond the data question. If students had the same choices tomorrow, would the graph come out the same? This requires us to predict by using our existing knowledge and knowledge developed from reading this graph. However, it's something that's not explicitly nor implicitly stated in the graph. But we can say that would the graph come out the same? Most likely no, since we know that people's preferences for lunch is something that's going to change day to day.